Do you like writing all of your code on a single line? Well, in this case, you're gonna love this video and I'm gonna hate making it because you shouldn't. So imagine you have some branch. If condition, then do action 1, else do action 2. We can actually write this on a single line. Condition, do action 1, do action 2. Now, what is this? This is called a ternary operator. If the condition before the question mark is true, then the first expression after the question mark gets evaluated. So we call the function do action 1. But if condition before the question mark is false, then we call the function after the colon instead. This is equivalent to an if-else statement. And I'm really scared of saying this, but ternaries are faster than if-elses. However, I don't personally use them that often. What you see here is very not complex, easy to read code because of how not many things there are. And ideally you want your code to look like this, more or less. But often it won't. So having an actual if-else separates that code into more readable lines than having them all on a single one. So imagine you have a question, but what if I need to nest my if things, like if condition 2? Well, first of all, don't use a guard clause instead. But in case you haven't watched my video on them, maybe you still do. And in that case, you can do the same thing with ternaries. But I'm gonna nest, yeah, obviously I'm going to nest them, but I'm also going to format them in a way where they're a bit more readable. So, condition. If condition is true, then if condition 2 is true, then do action. Sure, let's make it 1 once again. But if condition 2 is false, then we do action 3. So you can indeed nest ternaries. And this looks fine. At one point I actually thought that this is equivalently readable to a normal if-else if. And I still think that anyone that complains about this being unreadable is just bad at reading ternaries. However, I don't use them like that anymore at all. I think it just kind of looks ugly and unnecessary. The speed gain that we do, get from ternaries simply isn't worth it. And I don't use ternaries that often anyway, even if it's just a simple expression. However, that's the only situation for me where using them makes sense. Just something very simple that doesn't have nesting to maybe bind to a variable, which I'm going to show off as well. But if you have it all on a single line, well, now it's increasingly difficult to understand what's happening here. Like, what goes after what? After you sit around like 10 seconds on the line to try to figure it out, you probably will. But in a real situation, the code will look more complex, so it will take even more time to understand it. And what's the gain, really? Not much. Developer time is far more expensive than performance. But the cream of ternaries is assigning to variables. So say variable, let's call it, I don't know, is old enough? I'm bad at naming. So if is old enough, then we age more than 18, more and equal to 18. So if older or is 18, then true, otherwise false. And this is pretty much the perfect use for ternaries, because the other way you would do it is if is old enough, if age bigger or is 18, then is old enough equals true, else is old enough false. Which is fine, but really unnecessary. And this, clean and simple, I would even argue that this is more readable as soon as you understand what ternaries even are. And that's pretty much it about them. I don't really recommend overusing them, but I had a ternary phase as well. The only restriction with them is the fact that you can't use keywords. So things like if, else, loop, files, continue, break, and some other stuff are keywords. But ternaries only accept expressions. So condition value 1, value 2. But maybe instead of value 2, you want it to loop and do something else. Well, you can't do that. Loop is not an expression, it's a keyword. So you can't use it in a ternary. However, you could use that in a normal if, else if, so on statement. So that's the difference you have to think about. Another thing that I want to cover in this video, because it's kinda close, is the interesting logic behind this operator and this operator. So there's such a thing as short-circuiting. I'm pretty sure that's how it's called. Okay, so imagine you have two conditions, condition 1 and condition 2. This whole expression will return true only if both condition 1 and condition 2 are true. And then we have the same thing, but with this operator. So condition 1 and condition 2. This works differently. It will return true if either of them return true. Meaning, if this condition is true, it will just return it. Now, to change what we're actually doing here, let's add var. So we bind that to a variable. And what if this condition is actually a function that gets something? Like, I don't know, gets is old enough. And let's mark it normal. Okay, and condition 2 is get is, I don't know, tall enough? Maybe you're checking for kids in a like shopping center, I don't know. And this starts to have a different meaning, this operator. Because if this function returns true, then we don't need to check this expression at all because of how this operator works. So short-circuiting is essentially don't check for things if you don't need to. It's the or operator, meaning if anything is true, everything is true. So if this function is true, we don't care whether this function is true or not, because we already got a true value and in the end it's true. So it just discards checking everything after. In other words, if this returns true, then that's what we get to the var. But if this returns false, then we do indeed get to check this function as well. And if this returns true, then that gets returned. And because of how AHK works, everything is either truthy or falsy. I don't know why we call that falsy and truthy. We programmers are really fucking weird. But essentially, 0, an empty string, pretty sure an empty array, and not sure about an empty object, could be true somehow. So yeah, these three things are false. Everything else is true. So maybe instead of get is old, which would return a boolean, this function returns a string. And if it returns an empty string, then we get this. Essentially, we can use this operator to get the input, or rather the output of two different functions and pick whichever one actually returns a value. Very useful. And it's really ironic that I'm talking about this having never actually used this in code. It sounds very, very useful. I'm not sure why I haven't. So try this out. Maybe you find a place where you can use that yourself faster than I will. I kinda hope not though, because yeah, I should be using this. It's pretty neat. So the same idea applies to this operator, but in the opposite way. Everything needs to be true for this expression to be true. Meaning, if even one thing is false, then everything is false and we don't need to check anything else. So, once again, we can have these two functions that return strings or anything else really. If this returns true, then we discard this value. Why? Because we end up returning the last value in the expression. So in this situation, condition 2. If we had more conditions, condition 3, then we would get returned this thing. So if this is false, we get false returned. But if this is true, we don't care about it anymore. Sounds like a bad relationship. That's programming for you. Okay, the last value was true. What is this? False. Great, now it's false. We get to check a bunch of stuff in the functions that would be in these conditions to eventually get a value that we want. Maybe it's just a string of operation we need to do for checking some values, and in the end either return false or return true, the actual value. Indeed, maybe you have some input from the user, you have input, and you need to check it, and you have multiple functions for it. Maybe is a string function that takes input, then I don't know, is long enough? Why is that even a concern? Then I don't know, is just alpha? I meant alphanumeric, but that sounds just funnier. So input, and then we do to var. Great, this returns, say, true. Great, we check the next thing. Is it long enough? Yes, it is long enough. Great, is it just alpha? No. So in the end, this var, which really should be is correct, now it's false because one of these things is false. But if it's just alphanumeric, then it also returns true, and is correct ends up being true. And then you can use it in your if statements. If is correct, meaning the input variable, then we do our stuff. So I hope you can see somewhat why this can be useful. And the other ways of and or, this and then this, don't allow that. because they don't have short circuiting. So in this situation, if this is true, this still gets evaluated. So make sure to have double as always. It's also more efficient when you're not using this technique, and it's useful when you are. So if this was useful to you, leave a like, press a comment. What? Leave a like, press a comment. I'm forgetting my outro, honestly. If you have some questions or suggestions, definitely subscribe so you don't miss my content, but most importantly, stay fresh, cheese bags. I'll see you in my next video. Bye bye!